let's just see the next construction, which is related with the basic construction. So construction number 2 was like to construct the perpendicular bisector of a given line segment. So we have to construct the perpendicular bisector of a given line segment. So let us suppose if I'm taking any two particular points over here, such that A and B are the 2 points that we have, and I'm joining these 2 points all together such that it forms a line segment. Now further I have to construct the perpendicular bisector. So using the compass and taking A and B as the center, and taking the radius as more than half of AB, I'm marking the arcs above as well as below. So taking A and B as the center, the radius should be more than half of the BA, such that I'm marking the arcs up as well as below, and whatever be the point of we can say the point of intersection of these arcs. So let us suppose this one is my first arc and this one is the second, and let us suppose if I'm joining the point of intersection of both of these particular 2 arcs in or with the help of a straight line of this form. So this line actually represents the perpendicular bisector. But let us suppose if I'm joining this point of intersection with A further, and further I'm joining it with this particular point of intersection. As you can see, I'm joining all the points of intersection with A and B, such that I'm calling this point and this point as nothing but P and Q. So as you can see, we have P and Q. So this line PMQ is the perpendicular bisector of the given line segment, which means that they are forming an angle of 90 degree over here as well as over here as well as over here and here, and so goes on. So we just have to first of all write the steps of constructions that are related with it. So let's just draw the steps of construction. So the very first is taking A and B as the center and radius more than half of AB. Draw arcs on both sides of the line segment AB. So as we did over here, we have drawn the arcs on both sides of the line segment AB. So this is nothing but a step number 1. Let's just see the step number 2. So the step number 2 was let these arcs intersect each other at the point P and Q and join P and Q, and further after joining P and Q we can join all the points all together as let PQ intersects AB at the point M, and then line PMQ is the required perpendicular bisector of AB. So this is nothing but the required perpendicular bisector of AB. So actually I've joined these lines for the further proving that this particular angle over here, that is PMA or PMB, is actually 90 degree. So in order to prove that, I have joined these lines all together. So let us suppose if I'll prove it further that the angle PMA and PMB is nothing but coming out to be 90 degrees. So let's just see how we can prove it. So these are all the steps of construction that are related with this particular construction. So let us suppose if I'm proving that this particular angle is 90 degree, this angle is 90 degree. Let us suppose if I'm proving this angle and further this angle is 90 degree. Let us suppose if I'm proving this angle and this angle is 90 degrees. So let us suppose if I'll write it over here that I am about to prove that the angle PMA is equal to the angle PMB, which is equal to 90 degrees. So this is the thing that we have to prove. So let us suppose if I'm talking about the whole triangle, let's just start the proof. So let's just start the proof. First of all, I'm taking the bigger triangle. So in triangle PAQ and triangle PBQ. So I'm taking the 2 bigger triangle, this one and this one. I'm talking about this one and this one triangle. So let's just see what we can say about the triangle. As first of all, let us suppose if I'm saying PA is nothing but is equal to PB. PA is nothing but is equal to PB because I can say these are equal arcs, or else I can write it as the arcs of the equal radii, because they are nothing but the arcs of equal radii. Like the reason we already have given in the previous construction, PA should be equal to PB. They must be the equal arcs, or we can say that they are nothing but the arcs of the equal radii. That's why they are equal to each other. And further we can say that AQ is nothing but is equal to BQ. The same reason that they are the arcs of equal radii. They are the arcs of equal radii. They are nothing but the arcs of equal radii. And furthermore, we can say that PQ is actually is equal to PQ. PQ is equal to PQ because it is nothing but the common side. So from SSS, this is side, this is side, this is side. From SSS rule, we can say that the triangle PAQ is actually congruent to the triangle PBQ by SSS congruency rule. And if they are congruent to each other, then what we can say about this angle, let us suppose if I am calling this angle as the angle 1, let us suppose if I am calling this particular angle as nothing but the angle 2. So we can say that if these two triangles are actually congruent to each other, then angle 1 should be is equal to the angle 2. Obviously, it implies angle 1 is equal to angle 2. How? By the rule CPCT, the corresponding parts of the congruent triangle should be is equal to each other. So angle 1 should be is equal to the angle 2. But this is not the required thing. We just wanted to prove that this angle is 90 degree. So let's just move on further towards it. So let us suppose now if I'm taking the smaller angles. Let us suppose if I'm taking the smaller angles as triangle PMA and I'm further taking the triangle PMB. So in these two triangles, first of all, I can say that the angle 1 is equal to the angle 2 because we already have proved it. So this is already proved. This is already proved, and further we can say that PA should be is equal to PB because of the reason that they are equal arcs, or we can say that the arcs of the equal radii. They are the arcs of the equal radii, and that's why they are equal to each other. And further, what can we say about the other thing, that PM should be is equal to PM. PM should be is equal to PM because this is nothing but a common side. So further we can say that with or using the SAS, the side angle and the side, by SAS rule, we can say that the triangle PMA is actually congruent to the triangle PMB by SAS rule. And if they are congruent to each other, it implies that, let us suppose if I'm calling this as the angle 3, let us suppose if I'm taking angle 3, if I'm taking this one as angle 4, so this one implies that angle 3 should be is equal to the angle 4 by CPCT. The corresponding parts of the congruent triangle should be is equal to each other. So angle 3 should be is equal to the angle 4. But again, we know one thing, that angle 3 plus angle 4 is equal to 180 degree. Why so? Because of the linear pair axiom. Because of the linear pair axiom, they are lying on a same straight line, which means that their sum should be is equal to 180 degree. But we know from the equation number 1 that both of these are equal to each other. So it means that if I'll substitute in place of angle 3 as angle 4, this would be angle 4 plus angle 4, which is equal to 180 degree. And further we can write it as 2 angle 4 is equal to 180 degree. And further we can write it as angle 4 is equal to 90 degree. So if angle 4 is 90 degree, definitely implies angle 3 is also 90 degree. And this is the thing that we wanted to prove. What we wanted to prove, that the angle PMA, the angle PMA, the angle PMB is 90 degrees. So at the end, from this particular result, we can say that the angle PMA is equal to the angle PMB, which is nothing but is equal to 90 degree. And if the angles formed over here is actually 90 degree, if this is 90, if this is 90, then definitely this PMQ is a perpendicular bisector of this line segment.